one of the major concepts of this chapter that we need to focus on is the mole. And we've been practicing with this for the last few days. So I just want to kind of go over this, start from the beginning, just one more time, go over the basics, get ourselves situated around what the mole is, and then do some practice problems, okay? So right off the bat, the mole is the SI unit for an amount of a substance. And mole can be abbreviated MOL. So when we're doing our dimensional analysis tables, I'd like to see that you write in MOL as your unit, okay? And it is equal to the amount or the number of particles in 12 grams of carbon-12. And what did we say that number was?
6.022137 times 10 to the 3.
Well, we're going to limit it at the three places past the decimal, but that was right, 6.022 times 10 to the 23rd. Okay, and that is, we call that number Avogadro's number. So Avogadro's number is the way that we can convert from moles to atoms. That's the number we would use. If we are not going to use atoms in the calculation, then you do not need Avogadro's number. Okay? But the reason we start by talking about Avogadro's number is because the way that the mole was created was by scaling up from the atomic level up to some level that we can actually measure, and that's grams. Okay? So the connection between atoms and something that we can actually put our hands on is Avogadro's number, that number of particles. Okay? Now, since we now understand a little bit about the mole, we can now use the mole to measure the mass of a substance. And we call that the molar mass. So the molar mass is usually written in the unit grams per mole, or grams over moles. Okay? And the really great thing for us that makes this really easy is that the molar mass of an element is numerically equal to the atomic mass of the element in atomic mass units. So remember, when we look at the periodic table and we look at the average atomic mass number up there, for instance, for carbon-12, we see that the average atomic mass is 12.01. That 12.01 on the periodic table means that one atom of carbon-12 has a mass of 12.01 atomic mass units. Well, in terms of the mole, we can just say that 1 mole of carbon-12 has a mass of 12.01 grams. So they're numerically equivalent, except the unit has changed. Okay? And that makes it really easy for us to determine what the molar mass is of an element. We just look at the periodic table and look at that average atomic mass number. So now that we've established these two things, the mole and molar mass, we can begin to do gram to mole conversions, and that allows us to add the math into a chemical reaction. Okay? But for right now, we're going to keep it simple, and we're just going to do some simple, easy conversions from grams to moles of elements. But what I want you to keep in back of your mind is that we are not only going to use moles for elements, this is also going to be usable for compounds and molecules. Okay? So here's an example. The molar mass of helium is 4.00 grams of helium per 1 mole of helium. If we wanted to find out how many grams of helium there are in 2 moles of helium, we can use the molar mass as a conversion factor. Okay? Now remember that conversion factors can be flipped or inverted because they just equal 1, right? So you can flip it or invert it to get rid of or cancel out whichever unit you're trying to cancel out of and then get into the other one. Okay? So on this calculation, if we want to know how many grams are in 2 moles of helium, we would set up our dimensional analysis table to say that 2.00 moles of helium times 4.00 grams of helium on top and 1 mole of helium on the bottom. And that way we'll be able to cancel out the moles. Our answer is left in grams. And here the math was pretty easy. 2 times 4 is 8. Okay? We end up with 8.00 grams of helium. Now, using Avogadro's number, we can determine how many atoms or how many particles are in a particular amount of the substance. Okay? So when we convert from a mass in grams to amount in moles, we would use the conversion factor of the molar mass, right, on the left part of the screen here. If we're going to go from moles to atoms, we're going to use Avogadro's number, right? If we want to go from grams to atoms, though, the chart that I had you draw didn't have the arrows at the bottom. The chart I had you draw simply had going up to moles and back over, right? Remember that the other day? Okay. Look at the bottom of this picture. What's actually happening there?
They're just putting them together.
Yeah, to go from grams to atoms, you have to use the molar mass. And you have to use Avogadro's number. Okay? So moles are our sort of connect grams to atoms. All right? So here's another sample problem. What is the mass in grams of 3.5 moles of copper? So we start with what we're given, 3.5 moles. The unknown is the mass of copper in grams. And this is the basic way we're going to set up our problem. We're going to use the molar mass of copper to convert from moles to grams. Sorry. So 3.50 moles of copper multiplied by the molar mass of copper, which is 63.55 grams per mole. What would happen to our moles here in this calculation? It would get canceled out, right? By setting this up with the moles on the bottom, it would get canceled out. We end up with 222 grams of copper. Okay? Why is there only 3 significant figures there? Because the number you were given at 3, right? Why do we not look at the molar mass for sig figs? Good, because it's a conversion factor. How many sig figs does a conversion factor have? Infinite number of significant figures. Good. Okay. Another sample problem, converting from grams to moles, going the opposite direction. The only difference here is we're going to put moles on top this time. Instead of having the moles on the bottom, we put the moles on top and put grams on the bottom, because what are we trying to cancel out? What are we trying to cancel in this problem? Grams, right? So we put the grams on the bottom, they will cancel, leaves our answer in moles. Now we're going to convert from number of atoms to number of moles. What are we going to have to use in this problem as our conversion factor? Good, Avogadro's number. And Avogadro's number over 1 mole or under 1 mole equals 1. So the conversion factor here, depending on what you want to get rid of, in this case we wanted to get rid of atoms, so our answer would be in moles. So atoms goes on the bottom, moles goes on top. Okay? Another sample problem. What is the mass in grams of that number of atoms? So this is probably, of these easy ones, this is the most complicated one. But really, this one's not even that complicated. If you look at it in this stepwise fashion, you're just going to have to use both of the conversion factors for the problem, right? Because you're traveling the furthest, from grams to moles, and then from moles into atoms. Or, in this case, atoms into moles, and then moles into grams, right? So the math would look like this. 1.20 times 10 to the 8th over 1, right? Multiply that by the molar mass. I'm sorry, not the molar mass. The number of atoms in a mole, right? And then, now that you have moles on top, you multiply that by the molar mass, you end up with grams on top. Atoms cancel, and then moles cancel. You're left with your answer. Okay?